Welcome to my project bazaar.com. Here we are going to discuss about the cooperating virtual memory and write buffer management for flash-based storage system. In our project mainly focus on the reducing wire activities, and flash memory is an efficient way to improve the performance and the intrusion of flash memory. Management schemes on virtual memory have not yet considered the existing of WBC equipped in flash memory. In our base paper, they proposed the cooperative management schemes for virtual memory and write buffer to maximize the performance of flash memory based on the system. In this work, they proposed CLC combined with FAP with buffer to further improve the overall system performance by working with virtual memory management collaboratives. In our enhancement, we propose a new management scheme for virtual machine as well as WBC cooperative for flash memory based on system to reduce write activities and to improve input-output performance. Hence, in this process, we implement the WPC LRU and the PCLRU for VM management and WPC management respectively. This series architecture can be implemented in VLSI platform in the form of VHDL language. Virtual memory is a memory management technique that is implemented using both the hardware and software. It maps the memory addresses used by a program called virtual address into a physical address in computer memory. Main storage is seen as by a process attack appears as a continuous addresses space of collection continuously segments. The operating system manages virtual addresses and the assignment of real memory to virtual memory. Address translation hardware in the CPU, often referred to as a memory management, automatically translate virtual address to physical address. Software within the operating system may extend these capabilities to provide a virtual address base that can exit the capability of real memory and thus references more memory than this physical present in this compare. A register is a small amount of storage available as a part of CPU or other digital process. Such registers are addressed by mechanism other than the main memory and they can be accessed more quickly. Almost all computers load store addresses or not load data from a larger memory into a register where it is easier to for arithmetic manipulation by some machines instruction. Now we are going to discuss about the flow diagram of our process. In our flow diagram represent the flow of our process. First of all, we give the input to virtual memory and we write enable signals. The virtual memory noted into the address information and the how many pages are required estimated first. In case of if you want pages increase, then update, then resend the data. In case of pages required less than to form the cluster, the cluster allocate the page. From the cluster output from allocate the each and every page. It represents the data stored in a particular pages. The allocated pages final pass into the output. The output is based on the our cluster formation. In case of we need particular output, we just search the cluster information. Now we are going to discuss about running procedure of our project. In our project we have four steps. First step we check the syntax error, then second step we generate the RTL schematic diagram, then third step we generate the technology schematic diagram, then finally we generate the simulation waveform. Now we are going to the first step. First select main function, then select check syntax. Now we are going to check the syntax error of our program. In case of any error and warning that displayed in our console log. In our program we have no error, therefore now we are going to the second step. Select view RTL schematic and run that. Now we are going to generate the RTL schematic diagram. Add and then create schematic. This is our overall RTL schematic diagram. The CMOS byte LUT address clock set RDLUT reset read WS command byte. These all the signals are our input signals. Data EBB plus LUT data byte native channel enable native output enable negative, reset negative, write enable, W enables, WEVP command out, flash. These all are our output signals. Please wait. This is our internal RTL schematic diagram. Now we are going to do the third step. Please select View RTL technology schematic diagram, then add, then create schematic. This is our overall technology schematic diagram. Now we are going to generate the internal block of our technology schematic diagram. This is our internal technology schematic diagram. In case of you want to zoom it, please select particular line. Now we are completed up to 3 steps. Now we are going to the final step. In this technology schematic diagram consists of number of LUTs and flip-flops. Then select simulation, then select main function, then select simulate behavior model and run it. Now we are going to generate the simulation waveform. It is based on our output signals. First we give the reset condition set to 1, clock value set to 0, CS value set to 1, ramp height set to 1, and CMT data value give it any input values. It is a 8-bit signals. RLD LUT is value set to 0. Then LUT address give it any randomized. Okay, it is a 24-bit signals. Then we give the flash values. Give the RI value set to 0. Okay, now we are going to the running of our program. Then we give the, now we change the input values. RDLUT values set to 1 and clock value set to 1 and reset value set to 0 and run our program. Then again change the clock values set to 0, then again change the clock value set to 1. Now we change the WCM path value set to 0 and clock value change it to 0. Now we have changed the values. Read LUT is set to 0 and run it. Then again change the clock value set to 1. Now we got our output waveform. This is our overview of simulation waveform. Now we completed our running procedures. Thank you.